Okay, so Professor Anderson, welcome again to the University of Padua. So you are coming from University of Oxford, which is also a very old, pretty old university, just as University of Padua. So I wanted to ask you, like, what's your concept about innovation in terms of science, and specifically, you can comment on chemistry, organic synthesis.
I think organic synthesis actually faces many challenges in innovation. People describe organic synthesis as a mature art, but I think those of us who work in this field do not think this is a mature art because we have many demands placed on us these days for sustainable synthesis, the supply of chemicals, shorter routes, cheaper, more efficient. These are demands that are very hard to meet in the lab. So I think innovation is required to solve these problems and make molecules quicker, more efficiently for the demands of society.
Yeah, that's true. Yeah, now that you're commenting on this, like your former training is as an a synthetic organic chemist. So you are very strong on total synthesis. So do you think that still total synthesis is something that could be applied in these current days? Is it just because of the beauty and the ability to build complex molecules, or do you think that it's something that should be still considered as an important field among organic chemistry?
I think it's a very important field because the synthesis of a natural product is the same as the synthesis of a drug.
Yeah.
Okay? What we need are short routes, more efficient, better control. And so in the past, certainly, there was an idea that a molecule is beautiful.
Yeah.
So now how do you choose the molecule you're going to work on? I think not only does it need to have some attraction to you, but also it has to serve a purpose. It must be a useful molecule, right? And so there's an element of, it's a field that I don't think will go away because synthesis means just preparation of a molecule. It might be a natural product or it might be an artificial molecule, but also the training. So, when we think as synthetic chemists, right, we need to be creative, adaptable, and, you
Innovative.
get that, innovative, you get that from the challenge that these complex molecules present to you.
And now speaking about application and about molecules that should serve for something, your research group is currently, I can say that it's a pioneer group. You're a pioneer on the renaissance of propellanes and these three-dimensional scaffolds. Do you think that the application of this synthesis is going to have like a real impact, a tangible impact? Is it having it now?
Yeah, I mean, I'm aware, as I mentioned today, of two examples of bicyclopentanes that are in clinical trials from chemical companies. But of course, the challenge is to translate the academic level synthesis to process scale.
Yeah.
And whether the propellane molecules can truly be scaled in a manner that makes them practical for industry is a quite interesting question. But, we have other technologies. So if you can make a propellane in flow and then use it directly, then potentially that chemistry is quite scalable.
Perhaps your group and the advances of your group are going to diminish this gap between industry and academic research.
We can only hope.
Let's hope so. And as a last question, if I may ask, like you are very strong in total synthesis. Do you have like a preferred favorite name reaction?
Oh, now that is a tricky one.
Okay.
A preferred named reaction. Actually, I should take inspiration from my postdoc mentor for that because Eric Sorensen, I remember, would describe many pericyclic reactions as venerable. And so, maybe I'm going to be a bit old school and say the Diels-Alder reaction is probably one of the best synthetic chemistry reactions. You create a six-membered ring with up to 4 stereocenters in one step.
Yeah, that's true.
That's a powerful reaction.
Well, thank you so much for being here, and until next time.
Yeah, thank you.